All right, everybody. So now this is going to be the metamorphic rocks questions that we're going to go over. So number one says, base your answer to the following questions on the passage below and on your knowledge of earth science. Once again, one of the things I recommend is going straight to the question first. Identify the change in pressure and the change in temperature that most likely occurred to metamorphose the sedimentary seafloor bedrock into Carrara marble. One of the reasons why I asked you to go to the question first is because sometimes you can know the answer without even reading the passage. The passage can help, but without even reading the question, there are clues that can help you to get the answer. So based on the question, they want us to know the change in pressure and the change in temperature. So there are two responses to this question, all right, that occurred to metamorphose, right? That word metamorphose, it seems a lot close to metamorphism. And when I look on metamorphism, right, when you look at the rock cycle, because that's where I see where more metamorphism is, where metamorphism is, right above that, it says heat and or pressure. So I know that in order for something to metamorphose or go through metamorphism, that means that we need to add heat and add pressure. So you can say it. In order for metamorphism to occur, you are adding heat and adding pressure. So if I'm adding heat and I'm adding pressure to change the rock from sedimentary seafloor to marble, right? And I already see that marble is already a metamorphic rock, right? Because I'm looking in the metamorphic rock identification section and I see marble here. So therefore, that means I need to add heat or add pressure. So what happens to my pressure, my change in pressure? Pressure increases. When they want to know the change of something, they're asking whether it increases or decreases, all right? And then I'm looking at for temperature, what happens to temperature? If I'm adding heat to change the rock into a metamorphic rock, that means my temperature also increases. And that is your answer for question number one. Pressure increases and temperature increases. You have to include both in order to get credit. If you only added one, you would get no credit. There is no half credit for the regions. All right. Number two, it says, base your answers to the following questions on the cross section below and on your knowledge of earth science. The cross section represents rock units labeled A through E that have not been overturned. A lava flow is represented between rocks unit A and B. Letter X represents the location in the igneous rocks. It represents the location in the igneous rock. Which metamorphic rock most likely formed at the interface between rock unit B and the igneous rock? So the igneous rock is right here, right? Because you see it's labeled with all these different lines scattered around. So X represents the igneous rock. B is the rock unit they're talking about. So they're talking about what's happening here. Remember that we learned, and I'm going to go to my notes really quickly. All right, give me a second to open up. It's not opening up. Okay. When I go to my notes very quickly, right? Remember how we stated that you can have a sedimentary rock. And if it's by magma, because magma is hot, this area right here in between can actually change from a sedimentary rock to a metamorphic rock. And they call this contact metamorphism. So therefore, I'm going to go back and look, and I'm going to see what rock most likely formed in this unit from contact metamorphism, right? So rock B is what type of rock? When I'm looking at this symbol for rock B tells me that it is sandstone. It is sandstone, right? You see how the symbol here for sandstone, it looks very similar to the symbols in rock B. So I know that the rock B is sandstone. I know that rock B is sandstone, right? I know that this is sandstone. So now I need to find out what rock, when it goes through metamorphism, changes from sandstone to a metamorphic rock. When I take a look, and I'm going to go to my metamorphic rock, I see right here, there is only one rock that changes from sandstone to a new metamorphic rock, and it is quartzite. All right? You see how quartzite is a metamorphism of quartz sandstone, and all of these rocks can form from regional or contact metamorphism. So the fact that I see contact metamorphism means it has to be a rock that can change through contact metamorphism. And so that's the reason why it is quartzite. Because it took sandstone, went through metamorphism to turn into quartzite. And so it is choice A. Number 3. Let me clear this off. Number 3, it says basic answer the following question on the graph below, which shows a generalized sequence of rock types that form from the original clay deposits at certain depths and temperature conditions within Earth's interior. All right. Then we get the graph. It's giving us these different rocks, and it tells us the depth, right? So as you go deeper into depth, it tells us what's happening to these rocks. This symbol means that at these point temperatures, the rock melts, okay? And so let's see. Explain why gneiss would not form at a depth of 27 kilometers and at a temperature of 800. So I'm gonna go to 27 is somewhere around here, right? 27 is around here. All right. I know my line is not completely straight. And it says at a temperature of 800. So 27 is here and 800 Celsius is right here. So they're asking, why is it that gneiss would not form at this location? Why would it not form at this location? Well, what is this symbol right here? If my dot is here, where these lines of symbols are, what happens at the lines? It says right here, at this point, at these temperatures, rock melts. So why wouldn't gneiss be created at a depth of 27 kilometers and 800 Celsius? Because at that temperature, at this point, at this temperature, the rocks melt. That is your correct answer. At this temperature, the rock melts. That's why gneiss would not be created here. That is your answer. All right. Number 4. Number 4 says, metamorphic rocks form as a direct result of what? Anytime you get confused and you're just like, man, I forgot what process creates metamorphic rocks. Go to the rock cycle. Look at metamorphic rock. Look at the process right before. Look at the arrows that's pointing to metamorphic rock. All of these arrows that's pointing to metamorphic rock, I see metamorphism, heat and or pressure. Metamorphism, heat and or pressure. So that lets me know my answer has to include, when I'm dealing with creating metamorphic rock, it has to include heat and or pressure. And that's why the correct answer is choice D. All right. And number 5. Number 5 says, which metamorphic rock will have visible mica crystals and a foliated texture? Which metamorphic rock will have visible mica crystals and a foliated texture? So therefore, what page of the reference tables am I looking at for metamorphic rocks? Page 7. Page 7. All right. So it tells me which metamorphic rock has visible mica crystals, right? And a foliated texture. When I'm looking at texture, I see foliated. So number 1, I'm only looking at the rocks that have a foliated texture. That means that it's going to be any one of these rocks here. Any one of these rocks here. All right, any one of these rocks here is a foliated texture. Then it says, which has visible mica crystal. Which has visible mica crystal. So when I take a look, which has visible mica crystals, it says right here, right? Because all of them have mica, right? Slate, phyllite, schist, and knight. I have to look at the comments to see, hey, maybe there's some information about visible mica crystals. When I'm looking through the comments, look what I see right here. Mica crystals visible. Mica crystals visible. And the fact that I see that is going to be the rock schist, which is choice C. All right. That's for question 5. The next video will show the rest of the questions.